Hello everyone, Ebuka here, and today we are going to be looking at object-oriented programming concept 2. In the last class, we looked at the first three concepts under object-oriented programming. We looked at the concepts of classes, we looked at objects, we looked at inheritance briefly though. So today we are going to be moving ahead and looking at interfaces and abstract classes. Okay. Well, before we dive into what we have for today, I'll quickly answer some questions you guys left after the last class. Okay, one of the questions I saw that someone asked was the use of the this keyword. Okay, this is the code from last class, though I just modified some things to make it look cleaner. Okay, so one of the questions I had really was the function of this keyword. Now, this keyword is used to refer to the particular object that has been talked about. Let me take this off. We'll come back to it later. This keyword is used to refer to the particular object that is created from the class. For example, if okay, the best way to illustrate is by giving an example. If I come to this car class that extends vehicle, I might want to add a function that will change the current gear of any car. So to do that, I can simply come here and say, okay, void, and create a function, a method, change gear, then it takes in the new gear. I think I've done something like this before in the last class. Alright, so we're taking in the new gear from in the function. So for us to be able to change the gear of any particular object that tries to make use of this change gear, we have to do this dot current gear, which is to tell that compiler that the current gear we want to change is the current gear of the particular object that is being referred to. So that particular object that is being referred to is this. So that's how we reference the object. So this dot current gear will be equals to new gear. So we can go for that to print the gear has been changed to, we can say this dot current gear, or we can just say current gear, since we don't have any variable that can conflict with it. So the gear has been changed to current gear. So if we do this, so let's create a new car is equals to car. So we can now change the gear of car by saying gear car dot change gear, and we give it 3. Now if you look at my code, I initialize the current gear to be 1. Okay, I think to make it easier, what we'll do, we'll first of all print car dot current gear. Then after changing the gear, we'll also print car dot current gear. Alright, and that's how we do it. Let's run it now. And you can see our console here. So the first place we have print car dot current gear, it's printed 1. Then after running this method change gear, which is this one, it's changed the current gear of this particular object. So if we create another object and change its gear, because we're using this statement, it does not affect any other it doesn't affect any other object, it just affects this particular car that we are dealing with. So that's why we make use of this keyword. Okay, so that's the first question. Then the second question, okay, not a question actually, but I'll talk briefly about overrides. We are not able to cover that in the last class due to time constraints. So I think we'll talk a bit on that before we dive into what we have for today. So now, this class vehicle can have its own methods. Remember, yeah, and any methods that the vehicle class has, bicycle and car will inherit those methods. So let's say we have void ignition. So let's say this is a method that the vehicle car has. So let's just say print vehicle has been ignited, or let's say started. Anyway, who cares? Alright, vehicle has been ignited. Now let's take this off. And now instead of creating a vehicle to test the ignition function, I can just create a bicycle. Bicycle bike equals to bicycle. Alright, then we can now have bike dot ignition, and you can see here the ignition method is not defined inside bicycle, it is defined inside vehicle. But because vehicle and bicycle is extending vehicle, it gets all those methods from vehicle class. Okay, so if we run this now, then it would now print vehicle has been ignited here. You can see that. All right, and if you create a car also, it will also have this ignition method, and it will also print out the same thing, vehicle has been ignited. Now what if you want bicycle class to have a different behavior for ignition? What if you want so that when you call ignition on a bicycle, instead of printing vehicle has been ignited, to print bicycle has been ignited? Now how we do that is by using overrides. Alright, we'll make use of the override notation in order to override this method, ignition method, that's provided by the vehicle class. So I can combine it here and write at override. This is how we override in that. Alright, so then you can retype that method, void ignition, if I can spell that correctly, ignition. Then we change what we want to happen when ignition is called. So we can say bicycle has been ignited. Alright, as you can see, these two are bearing the same name because here they are referring to the same method, but because we're using override here, anytime you call ignition on a bicycle object, it is going to override this particular method here and give us bicycle has been ignited instead of vehicle has been ignited. So if we run this, and yeah, we can see it. So that same ignition function now is giving us bicycle has been ignited. Now this override behavior is something that is used very deeply even in the Dart programming language, because for example, let me give you one of the scenarios where Dart uses override. In one of the cases, okay, let me explain. Any class you create that can be used to create objects deep within the Dart language, that class you create inherits from another class within that called the object class. So now, if I write class vehicle extends object, it's still the same thing as just writing um, class vehicle without writing this. Because even if you didn't write that, that within itself knows that any class you're creating must extend object. Now you would ask, why am I talking about extending objects? You will see something. If I print bike, which is created from the bicycle class, dot. Now take a look at these functions that are given to us here. You can see to string. ToString is a method that converts our bike to a string. Let's run this and see what it will give us. So print bike.toString, and it prints us instance of bicycle, telling us that bike is an instance of bicycle. Now that is the default behavior that was defined in this toString method that is contained within this object. It just prints the name of the object. So now if we want to change this toString, that this bicycle class is also inheriting from objects, so we have bicycle extend vehicle. Okay, I think let's make use of, instead of using bicycle here, let's use vehicle, so we do, to avoid confusion. Vehicle, so let's call it vh. So if we print this, it should print instance of vehicle, so instance of vehicle. So that's the default behavior of this toString. But now we ourselves can decide to modify how that prints this toString from this object class. So how we can do that now is by coming down here within the vehicle class and writing at override. Then we now write the method toString. So now it will override the definition of this toString method that is defined within this object class. This object class, remember, is inbuilt into that, so you shouldn't worry yourself of where this is coming from. And even if we remove this, it will still work. It is not going to throw any error on our override. So let's continue. So string, we want to change, we don't want it to display instance of vehicle, we want it to display the properties. So we can do return, we can say let return vehicle, then display the properties of vehicle. Let's say numbers of tires, number of tires should be number of tires. This number of tires, it's coming from this place, which is the number of tires of the object. So we can also have color as color. All right, and that's it. So if you want to also make use of that this keyword, you can still come here and do something like this dot, but in that case you have to wrap the two of them in square brackets. So this dot number of vehicles and this dot color. All right, so now if we come here, let's define use the constructor to define variables for the vehicle class. So let's come and have number of tires 3 and color is equals to blue. Now if we try to print out vehicle dot toString again, remember previously it was printing instance of vehicle, which is the way the object class within that tells any class to print to perform toString operation. But now we have override it. So if we run it now, you can now see it's printing out vehicle, number of tires 3 and color blue, which is what we have defined it to, what we have made it to return to us the using our overriding the toString method. So I hope that wasn't too complex. I believe you understand. If you still need more clarification, you can still let us know in the Slack channel. A lot of mentors are willing to help. So let's dive into what we have for today. OOP concepts. Yep. All right. Let's present. Okay, so we're starting with abstract classes, if I'm not mistaken. So what are abstract classes? Abstract classes are the classes in that has one or more abstract methods. One or more abstract methods. We can declare the abstract class by using the abstract keyword. Okay, This might look a bit complex at first sight, but let me try to explain it using the code we already have. Right now, if we look at this class vehicle, you will see that we can use class vehicle here to create objects, just like we can use bicycle to create objects. Now, there might be a situation we wouldn't want vehicle to be able to, we wouldn't want the vehicle class to be able to create objects because the vehicle class is just um, an abstract category. In that case, like we do not intend to use this vehicle class to create objects, but we just want other vehicles like bicycle, car, ship, or whatever to be able to extend the vehicle class. I don't know if you get what I'm saying. Um, is there any other way I can explain it? No, I think that's the best way. So we can decide to make this class abstract. Now, if we make this abstract, this will begin to throw an error. And if we hover over it now, you'll see they said abstract classes cannot be instantiated. So once you have created um, vehicle and made vehicle an abstract class, you cannot use the vehicle class to create objects anymore. But even though you can't use the vehicle class to create objects anymore, you can create other classes that extend the vehicle class, and those classes you can decide to use them to create objects. You understand? Now you start asking, what is the advantage of having um, making a class abstract? Now this is one of the advantages. Now take for example every every vehicle like a bicycle, a car, or a ship has a different way of performing ignition. Let's say for a bicycle you can ignite it by pedaling. Let's say a car you can ignite it by using the key. So now, since there are different variations, different things, different ways, different vehicles can perform ignition, we can just change this to an abstract method. An abstract method is one that doesn't have a definition. So what you just do, we'll take out this implementation of the method. So we'll take this out and we just put a semicolon there. So you can see what this is telling that is that okay, I'll come back to this error that is displaying here. Now what this is telling that is that any class that is extending or that is inheriting properties from vehicle must implement this must have an ignition method. But now, since the ignition method is not defined in vehicle, any class that is extending vehicle must define ignition method within itself. Now, normally bicycle is supposed to throw an error, but it didn't throw an error because we have come here and override what ignition should look like. But if we come down to car here, you see car is now throwing an error, and if you check here, they say missing concrete implementation of vehicle.ignition. So what that is trying to tell us is that we have not created um, an implementation for vehicle.ignition in the car class. So to fix that error, we'll come here below this method and come and define how um, the ignition method is going to work in the car class. So we can do that by overriding. We can do that by overriding the ignition method which we already have in the super class, which is the vehicle. So we can now have void ignition. Then we can now have print car has been ignited. Alright, so and as you can see, that error disappears. So we cool. So once again, you can see from here we just define whatever method. We just define whatever method. Do I say define? Yeah, we just define whatever method, but we did not create an implementation for that method. Adding your curly braces and writing code within is creating implementation. Well, we don't want to create an implementation for the ignition method. Hence, ignition method is regarded as an abstract method. So that's one thing to note. So abstract only abstract classes can have abstract methods. If I remove this abstract now, um, you can see that is now underlining ignition because we haven't created an implementation for ignition. So I'll just go back and put abstract in front and our error should clear. So since we have made vehicle an abstract class, now we can no longer use vehicle to create an object, but we can use bicycle. Okay, so I believe you are with me. So vehicle cannot no longer be used to create an object because it is now an abstract class. An abstract class is abstract. You can't use it to create an object. So you can only use other classes that are not abstract to create uh, an object. So let's move on. Okay, abstract methods are those methods which are declared without implementation. We have seen that the implementation is your curly braces where you write your code for the method in between. The concrete methods or normal methods are declared with implementation. Okay, so the opposite of abstract method is concrete methods, which are those that have implementation. So an abstract class can contain both types of methods. Okay, so I think you can see that in our vehicle class we had um, one function, is it print information or whatever, that was a concrete class. We implemented it there. There we had another method, ignition, which wasn't implemented, which was an abstract class. So that's just to tell you that abstract classes can contain both abstract methods and concrete methods. So let's move on. Okay, I believe we have done this. We have converted vehicle class to an abstract class. Okay, and we have created abstract methods, and I've explained the override notation. So I think we are good to go. So let's fly. Data encapsulation. This is a very important concept which I can't afford to skip when talking anytime I talk about object-oriented programming. Okay, data encapsulation is binding data and functions to use data that use data into one unit. So um, I won't go into too much details because data encapsulation is not as pronounced in the Dart programming language as it is in other programming languages like C++ and Java. But I'll just show you an example. Now, I think the best way to show an example is by defining a private string. Let me create something. Um, Let me just call it engine type. I don't know what I'm doing, but let's just put it there. Engine type. Now, what I just did now is data encapsulation. Now you observe that within this bicycle class, we have encapsulated all this data, all these properties into the bicycle class. We have numbers of tires. Now it have been merged into this bicycle class. We have color and model. So since all of them belongs to one object, you can see that we have grouped all of them and encapsulated them into the bicycle class. And since all of them belongs to the bicycle class, we can decide to make something like this engine type. We can decide to make it private so that it's not accessible from outside this class. Like if you come here now and try to print vehicle dot underscore engine type, if you try to do this, it's not going to work. Actually, it's not supposed to work because you have defined the engine type, you have defined it as a private variable, so it's not supposed to work. So this principle of being able to hide or contain data within a class is known as the principle of data encapsulation. So that's one. The second concept we'll look at there is that of polymorphism. Polymorphism. So it sounds like a big word, but polymorphism is simply the ability of one thing to exist in more than one form. So in this case, by performing inheritance here, okay, let me explain first of all. I've told you that polymorphism is the ability of an object to exist in more than one form. So in this case, you can see that bicycle the bicycle class has its properties, but also it can also take the form of the vehicle class. That's why if you ask that if vehicle, okay, let's call this bike. If you ask that if this bike is vehicle, it is going to print true because the bicycle class is taking the form of the vehicle class. So now that means the bicycle class is existing in two forms. It's existing as a bicycle and it's also existing as a vehicle. So that's polymorphism. As I said previously, I won't go into the details, but if you still want to know more, you can still ask your questions in the Slack channel and you'll surely get your reply. So let's go on. Data encapsulation. All right. Now, another important concept we have to look at is the concept of interfaces. Interfaces. Now, let's look at my definition here. An interface defines the syntax that an entity must adhere to. In an interface, you can declare methods which any class that uses the interface must override. Okay, so we talked about abstract classes. Okay, like here we created vehicle as an abstract class, but now in creating vehicle as an abstract class, we added, okay, this to string override. If we want to convert vehicle to an interface instead of being a parent class, what we can do, or let's say, let me create another interface that will make use of. So let's see, although let me check if I have an example here we can use. Oh wow, you have to use a very different example to do that. So let me open a new dart pad. So dart pad. So I'll take out all this code. So I just have to do this to show the concept of interfaces. So now looking at our definition of interfaces, it says in an interface you can declare methods which any class that uses the interface must override. Must override, that was the keyword there. So if you want to create an interface, according to this illustration, they say create an interface for registration functionality, and that registration functionality has methods such as sign up and login. So let me create this now. I can come here, down here, outside my main function and write. Your interfaces are usually abstract classes, so we can have abstract class registration interface. Then within registration interface, we can come here and write login, sign up. Can you see this? So by creating an interface, okay, that's say we should specify a return type. So let's add the return type of void for the both of them. Void. All right, and the error is gone. So by looking at this registration interface I created, any class that tries to use this interface must override the login method and the sign up methods. Any method that we put inside this registration interface must be overridden by any class that wants to use the interface. So for example, if we want to if we create a new class called registration real implementation, let me just call it implementation. Now, if we want this class to make use of the registration interface, we use the keyword implement registration interface. Cool. And we are good to go. Now, by writing that this registration real implementation is going to use or implement the registration interface, you will see that this begins to throw some errors. And if we overwrite it, it gives us this error, missing complete implementation of registration interface.login and registration interface.signup. All right. So what we have to do to clear this error is that if I come to my keyboard and press Option Return, or on Windows you can press Alt Enter, you will see the different things you can do. You see create two missing overrides. So if I select that, you'll see what happens. Okay, you will now see that um, as you can see, first of all, you can see that the errors have cleared. So what I did here is that these abstract methods that are defined in the registration interface, I override all of them. So by overriding all of them, I am implementing the registration interface. You will see if I just remove just one of these functions, if I don't override just one of those functions, you should see this error will come. So that's why my definition tells you that um, you can, okay, here did I write that? When a class implements an interface, it must override every method and instance variable of that interface. So that is why here we must override every of the functions and implement them. So we can just do print login, and we can just do print sign up. Okay, so let me attach something in front. Real implementation login, real implementation sign up, and we have implemented the interface. So now you start asking me, what are the benefits of using an interface? Well, a scenario in software development where you can use an interface is where you want to have multiple implementations for some particular functionality. Let's say um, you have different ways of logging into a website or logging into your application. So you can create an interfaces for login and sign up. Then you now create a class that implements registration interface and define how that is done in the first method which login can be implemented. Then you can create another class. So let me call this one registration fake implementation, and it will also implement registration interface. So as you can see now, these have implemented registration interface here, and it already has the way it's implementing it. So I can come under this fake implementation, option enter, option return, then create two missing overrides. So I can also come here and create another implementation for login and sign up. I'll show you how to use these different implementations in a bit. So let's just copy this, paste here, and copy this, paste here. We'll call this fake implementation, and this one fake implementation. Now as you can see, this login, so both of them, since both classes are implementing registration interface, both of them must override the login and sign up method. And as both of them are overriding the login and sign up methods, both classes must implement those methods in their own way. So the registration real implementation has its own method of implementing it, and the registration fake method has its own way of implementing it. So now let me show you how you can use any of these your implementations. Now we can come to our main.dat and write registration interface. Then we can call it registration interface. I'm creating an object interface, and we can make this to be equals to, now we can either write whether we want this registration interface to use the real implementation. So we can come here and say registration real implementation, if I can spell that correctly. Let me give space so you can see clearly. So we can either write this. If we write registration real implementation, we'll come and say registration interface, or let's just call this registration, or just call it reg. Then we can say dot login. Now you will see, because this reg is making use of the real implementation, if we run it, you will see that reg is going to print real implementation login, which is the implementation that is provided by this real implementation class. But if we still come here and change the implementation to fake implementation, which is the implementation that is coming from this class, and okay, there's no M. If we change it to fake registration implementation and we run it, you can see it's now printing fake implementation. So this way you can easily switch between any implementation you want. You can easily switch between your real and your fake implementation. So that is one of the various use cases which you use interfaces. We are going to be using interfaces a lot, especially when we start dealing with consumption of APIs and stuff like that. But this is just basic knowledge. So let's proceed to the next concept. I really hope you do understand the concept of interfaces now. Okay, present. And finally, one of my favorite features of OOP in that especially is the mixin. Alright? A mixin is a class that contains methods for use by other classes without having to be the present parent class of those classes. Let's take it again. A mixin is a class that contains methods for use by other classes without having to be the parent class of those classes. Now, what I mean is that if we go to this, our initial example, using the vehicle and bicycle and the rest of them, now you observe that the only way that bicycle can get this ignition method is by extending vehicle. That's why we have to come and override it here. Now let's say if we want to perform an action, let's say we want to do bike.ride. We want to perform this action or this method ride. Now you see that because we have not specified this ride method inside our bicycle class, and we have not written or implemented the ride method inside our parent class either, ride will throw an error. But what if there's a way we can create something, or we can create a place where bicycle can be fetching methods from? So let me show you something. We can create a mixin for that. So mixin bicycle mixin. Okay, this will look very confusing at first, but trust me, you will grab it in a bit. Okay, so now I've created a mixin that contains an implementation of the ride method. But now we have to look for a way to make this bicycle class to be able to have access to this ride method. Are you with me? So this is where mixins are very important. By using the keyword with, if I come under bicycle here and write with bicycle mixin, you will see that all, first of all, you see that the error has cleared here. Now what happens is that inside this our mixin, any method that we declare inside this mixin will be accessible from the bicycle class, because this bicycle class is now making use of the data from the bicycle mixin. I hope you understand. I really hope. So you can see we can use the bicycle mixin to create um, a method or create groups of methods that will be reusable by different classes. Now, for example, if we create a car, let's create a car here. Car equals to car. And we now try to perform car dot ride. Now, since we also haven't defined the ride method within car, there's no ride method. We only have ignition and change gear. There's no ride method. So ride will throw an error. But since we have already created a mixin that contains the ride functionality, we can come and attach that mixin to car, so that car will have that ride functionality. So we can do that by just coming after vehicle here. We can just come and write with bicycle mixin, and as you can see, the error disappears, showing you that now car can be able to perform ride functionality, even though the ride functionality is not defined within the car, but it is defined within a mixin which the car is using. So you can define as much um, methods as possible within this mixin that will be usable by any other class. So this is one of the ways to make your code look very clean by using mixing, so you can reuse codes, you can reuse different methods. So that's that about mixing. So if we come here and run, let me comment this out. If I come here and run, then okay, we can now see ride bicycle. The ride bicycle is now coming from the ride function that exists within the bicycle mixin. So that's why it's now running this function ride, and it's now printing out ride bicycle. So that's for mixins. You will see as when we start doing Flutter and we start doing form validation, you will see how important mixins could be. So let's go back, and I think we have treated all the topics. So we are going to perform this exercise in order um, to illustrate all we have learned so far. So let's look at it together, and then we'll now know how we'll model this class or this group of classes. So create a human superclass. So we are going to create a human class, and I'm thinking it would be an abstract class. Maybe when we start implementation, we will know. Now, human implements living thing interface, which has methods breathe and grow. Now, if from what we have learned previously, an interface allows you define it allows you define methods which any class that is using the interface must implement. So that's why we're creating a living thing interface, because every living thing must breathe, every living thing must grow. So, but the way a plant breathes, a plant is a living thing, yeah. The way the plant breathes is different from the way a human being breathes. You get? So now, when you are creating a human class, you have to implement living thing interface. So you have to implement the breathe method for the human. Then if you create a tree class also and implement living thing interface, you have to create the breathe, implement the breathe method for that tree class. Are you with me? So let's go on. Let's start creating this gradually. So let's create human superclass. I think I'll still have to open a new dat pad. So dat pad, and we'll have to clear off everything. So clear off all the code, and let's get started. So we can have class human. We don't know what will be contained in our human class for now, so let's just leave it blank. There we can create an interface. Remember, interfaces are usually abstract classes. In programming languages like Java, instead of using a class here, you would use an interface. You use an interface here, but that doesn't support doing that, so we have to use a abstract class instead. So living things interface. Now, living things interface has to contain grow. Let's say void grow and void breathe. Now, if you are with me, you understand that any class that tries to implement the living thing interface or try to use the living thing interface must implement these two functions. Okay, so let's go back to our instruction. Okay, then create a doctor class that extends human. Wow, human implements living thing interface. Let's do that first. So we can just come here and say implement living things interface. Now, by implementing living thing interface, that means we must define how. Okay, implement. Sorry, not implement. We must define how a human being breathes and grow. So we'll come here, option return, create two missing override. So now we can come here and define these methods. I breathe through my nose. Yep. What do I write here? I just write human growth. I don't have time. Okay. And this way, the human class has implemented living things interface. So I believe you understand. So let's go on. Create a doctor class that extends human class. So let's do that. Let's create a doctor class. So class doctor extends human. Now, as you know earlier, for the fact that doctor extends human, all this property, breathe and grow, will be contained within the doctor class. So if I just come here and write doctor, if I try to create a doctor object, doc is equals to doctor, you will see that when I write doc dot, you will see that the doctor can breathe and the doctor can grow, which are features of a human being. But since the doctor is a human being, the doctor extends human being, we now have those features. So let's go, let's leave that for now. So doctor extends human being. Let's go on. Now create basic medical procedure mixing with methods such as administer treatment and give first aid. Alright, so remember I told you a mixing allows a class have access to functions which it does not have within itself. So we can create a mixing basic medical procedure. Now it can have things like void administer treatments. Then let's say print administering treatments. Then we can have void give first aid. print give first aid. So now we have created a mixin called basic medical procedure. And the sweet thing about using this mixin is that a doctor now can have access to these functions or these methods that are contained in the basic medical procedure mixin. So you can just come here and add with basic medical procedure. So by typing this, when we come here and write doctor, doc dot, you will see now a doctor can administer treatment. You see that a doctor can also give first aid. Now you observe that all these functions I'm calling, they are not even, the doctor class is actually empty. It doesn't have any of those things. But due to the fact that the doctor class is making use of the basic medical procedure mixin, the doctor can be able to perform all these things. Now about code reusability, you can see that since we have this basic medical procedure mixin, I can easily use it to create a nurse. I can just come here and say class nurse, and nurse will use basic medical procedure mixin. And now you'll see if I come here and write nurse equals to nurse, you will see that even though nurse is also empty, since she is making use of the basic medical procedure mixin, you'll see that she also have access to this method. So the nurse can also administer treatment, and the nurse can also give first aid. So that way you have seen that we have reused this basic medical procedure mixin, and it is working for both the doctor and the nurse. And you have also seen that the doctor, since it is extending human, it can perform the methods of a human, which is breathing and growing. So with that, I believe you have gotten a full grasp of object-oriented programming. You have seen how object-oriented programming comes very close to real life. We try to represent everything in real life the way we understand it, the way we can easily relate to. So I believe with that we've come to the end of this class. Congratulations, you're now a DAT OOP ninja. So don't just relax there, you have to take more time to practice, and I believe at the end of everything, you understand everything better. So thank you very much. If you have questions, please leave them as comments or on the Slack channel also, so you get rapid response. Once again, on Ebuka, and I'm signing out. Thank you.